Hello everyone and welcome. In this video, we're going to be talking about Chapter 5, Section 5 from Grade 10 Mathematics book, the governmental curriculum. The title of this is basically Fundamental Trigonometric Identities, which we can simply say basically properties of sine and cosine and tangent. Okay, so here's some introduction on it. However, I really suggest we just jump into the topic itself, because in other videos you can find like some introductions and other stuff, basic stuff on it. Okay, so just as a quick reminder, basically, if you have a triangle like this, okay, this vertical side is y, the horizontal side is x, and the hypotenuse here is r. Basically, cosine will be always x over r, okay, the adjacent side to the angle. And then sine of theta will be y over r, let's say the opposite side to the theta over the hypotenuse. As I said, you should be familiar with these before you watch this video, okay? So this section is all about proving identities. Like you have an equation from the left side and the right side. You either start from here and you want to go there, or the other way around, okay? It's all about that. So the first one, it says, prove this equation. Okay, which equation? This one. Tangent of anything, or here we can say theta, it could be x, y, z, anything, is sine theta over cosine of theta. Okay. So, okay. All right. So you could either do this or do it the other way around, basically. So you either are given that tan of theta is y over x, and you prove it's sine over cosine, or you do it the other way around. We will do it similar to the book. It doesn't really make a difference. Okay, so the question in the book, since it says we show that it's sine of theta over cosine of theta, we do the same thing. Okay, we will do the same thing. Okay, so proof. How do we prove this? Okay, so first things first. Again, this is the left side of the equation. Okay, this is the right side. Preferably, we start from the left side and start expanding, meaning we make it bigger so that something cancels, for example. So starting from the left side, we have tan of theta, okay, which if you go back to the book, you can use this and just say tan of theta is y over x, okay? So tan of theta is y over x. Now, in order to get sine and cosine back, please take a look. Sine and cosine both include what? R, the hypotenuse, right? Since they both have it, okay, so we will add it to the equation so that both of them have it. And how can we do that? Basically equal, okay? So y over x again. Okay, in an equation, can I multiply by the same number above and below? Of course I can. So times r over r, okay? Or you equivalently, you can say I divide by r over r, okay? Which turns to what? It turns to y over r over x over r, okay? Which, if you have noticed already, y over r is what? Y over r is basically sine, right? And x over r is what? Cosine of theta, okay? So just put them back again. So you get sine of theta over cosine of theta. Okay, so as you can see, we started from tangent and we ended up with sine over cosine. Okay, one thing, this question could be the other way around. Basically, it could say, prove that tan is y over x, and then you use this fact. It will be the same thing, but you start from this, and then you get y over x after that. Okay, that's another way to have the question. Okay, so let's move on. In the book, after that, there is this example. Let me show you. So after example one, these are some trigonometric properties which we'll explain while we do example two. It says verify the identity. Which identity? Which property? This one. Sine squared plus cosine squared of anything, theta, x, y, z, anything, is always going to be 1. Now, one common mistake students make is that they think, so simple. Now, sine of anything plus cosine of anything, it's equal to 1, right? Well, that's not the case. Not always, at least. Okay? Um, they have to be squared. Just don't forget about that. Okay? So now let's do this here. Okay. So we want to show that sine squared plus cosine squared is equal to 1. Now, I can start from the left side and hope that I get some terms to cancel, and from there I get 1, okay? So let's write it again. Sine of theta squared plus cosine of theta squared. Okay. So again, you can go back and look what is the basic definition of sine of theta. Well, sine of theta is always y over r, basically. Okay? Plus, what about cosine of theta? Well, cosine of theta is also similar. It's x over r, all of it squared, right? And we know from the properties of powers that this squared is for the y and it's also for the r. And this one similarly is for the x and for the r. So as a result of all of this, okay, we will get y squared over r squared plus, okay, x squared over r squared. Now, if you have noticed, both of these fractions, they have a common denominator. Okay, the common denominator is r squared, like this. So in the next step, I can just say this is equal to, okay, write a common denominator for all of them. Look, first one, y squared, it doesn't make a difference, okay? X squared plus y squared. Okay, now one of the basic definitions when you have a right triangle, basically, let's look at it here. This is the Pythagorean theorem from grade 8 and like other grades, basically. So that two legs of a right triangle squared, the sum of two legs squared is the hypotenuse squared. Okay, so x squared plus y squared is always r squared. So this part becomes r squared, and we have already r squared below. Okay, so these two are the same thing, so we cancel them. We get 1. Okay, so we started with this, right? Sine squared plus cosine squared, and we got 1, which proves this identity. Okay, and there are similar identities to this from the book. Let me show you. Yeah, for example, this one. This is the same thing, but instead of starting with sine and cosine together, you can do the same steps, but at the end, here it says sine squared, right? You say, well, I move cosine squared to the other side. So now sine squared is equal to 1 minus cosine of theta squared. So this question is not different. It's the same thing with one extra step. So basically, when you reach this part, you just move the cosine to the other side and it becomes negative, okay? Yeah, and now we move to example 3. Example 3 has some details, okay? So it says write the expression, this expression, in terms of a single trigonometric ratio. So when it says single trigonometric ratio, you have the option to either choose cosine or sine. Okay, so in this expression, we have both sine and cosine. The question is asking us only write it in terms one of them, meaning get rid of the other one. So either change all the sines to cosine or the other way around. Okay. We will do it here. Okay. So again, this is not an equation, remember. It's not like that we want to reach a part where it's one or something else. We just need to get rid of one of these. We don't want both of them together. So 1 plus cosine of x, okay, over sine of x, all of it squared. Now you may be thinking, well, can we do this using r and x and y, the basic definition of them? Well, I would say yes, it's possible, but it's not the easiest way. And you might have some problems in the process, okay? So the best choice is to use the sine squared. You may be asking why? Well, because we just proved this identity, which is nice, okay? It turns into a 1. It becomes simpler, right? And there's the sine squared. So maybe we can use this, okay? Yeah, so we have 1 plus cosine of x. So we have decided that we changed sine into cosine, okay? And let me use another color, okay? So remember, the previous example, example 2, we show that sine squared, okay, plus cosine squared of theta is equal to 1. By the way, you have to memorize this one, okay? Now we need to find sine squared, okay? So imagine here you want this sine squared to be alone. So what do you have to do? Yes, you have to move this sine squared to the other side. So the identity becomes sine squared of theta is equal to, now it's alone on the left side, so you can replace it, 1, and then when you move it to the other side, the cosine, it becomes cosine squared of theta. Okay, so as you can see, sine squared is equal to this expression. Okay, so instead all of this, you could just write what? 1 minus, here it's used x as a variable, change the theta into x, doesn't make a difference at all, okay? 1 minus cosine of x squared, okay? Now, some students may say, let me cancel, it's the same thing. Remember, this is a positive, this is a negative. That's the first difference. And also, this is cosine squared. So it's two different things. Now, here to do anything after this, I have to explain a rule. You should be familiar with the rule, difference of squares. Okay? So a squared minus b squared is equal to a minus b, a plus b. By the way, you have to be familiar with this rule. Now imagine a is 1, okay? A is 1, and instead of b, we have cosine squared, okay? Doesn't that mean we get 1 minus cosine, okay? 1 plus cosine? Think about it. Cosine is b. Look, cosine is b, so minus b plus b. Look, just compare. And a is 1, okay? Like this. Okay, so just put all of that in mind before doing the next step. So now I can say 1 plus cosine, the above part, it doesn't change. The lower part, it becomes what? 2 brackets. Remember, 1 minus cosine times 1 plus cosine. So it becomes 1 minus cosine of x, of course, times 1 plus cosine of x in a fraction like this. And of course, you can give this a bracket. Now, you may have spotted the common ones. So we can say the whole bracket, 1 plus a cosine, and the 1 plus cosine below, they cancel each other, okay? So we are only left with what? In a fraction, when it cancels, there is only 1 above, right? 1 over 1 minus cosine of x. And as you can see, this expression only includes cosine, not sine and cosine together, okay? I was thinking about solving one more example. Let me do it so that we deliver the whole package. Okay. So now I was thinking about this one. Sine of x. The other one was sine, right? Okay, we change it. So cosine of x, this time in the numerator. And the other one was, let me see, it was 1 plus cosine. Okay, so this time we do 1 minus sine of x. Okay. Okay. Similarly, we just want to write it in terms of one of them. Now, since sine doesn't have a power 2, we want to change the cosine into sine. Okay. How do we do that? We write 1 minus sine of x similarly. Okay. How do you change cosine squared? Remember again, cosine squared plus sine squared of anything is equal to 1. This time we want to replace what? We want to replace cosine squared. So from this relation, how do you find cosine squared? You move the sine squared to the other side, like this. Okay. So you will have 1 minus sine of, let's say, x squared equal to cosine of x squared. So we can replace cosine of x squared by this expression. Okay. So yeah, simply we replace this expression, red part, with the 1 minus sine of x squared. Okay. And now the difference of squares, imagine this is a squared, and this sine squared is b squared. So sine is b. So we know that difference of squares gives you what? It gives you a minus b. I can do that. Let me do it. It gives you a minus b bracket, right? And then, so let's say it's like this. And then a plus b, okay? So we said a is 1, so we get 1 minus sine of x, okay? And 1 plus sine of x. And don't forget about the denominator, which is 1 minus sine of x. Okay? So at this point, you may have noticed 1 minus sine of x, 1 minus sine of x, they cancel. So we're only left with 1 plus sine of x over 1, which is simply 1 plus sine of x. And that's it for today's video. I hope it was useful. See you in the next one.